All right, good lady or good afternoon, ladies and gentlemen, or good morning if it's third hour. As you guys know, I'm not here today, but we are still going to be learning, as I mentioned yesterday before I left. So we are going to get going right away so that this video is as short as possible for your sakes. So let's jump right into it. We are covering the multiplication properties of exponents today. And let's go ahead and get into the actual presentation, go full screen. And here we go. Lesson overview. What we're hoping to have done by the end of the day is that you will be able to, one, identify monomials and ponomials, multiply powers and exponents, take the power of a power or an exponent and also their products, and simplify expressions involving exponents. Might sound like gibberish because it is, unless you know what you're doing. That's what I'm here for. Seems like a lot, yes, a little, but don't worry, you can handle it. It's all fairly intuitive once you get the hang of it. Part 1, monomials. We'll start off with a definition. It is a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. Sounds like junk, because it is a lot of junk. Don't worry, you don't need to write that down. That is on page, I believe it's 393 in your book. It's highlighted in bright yellow letters. It says monomial, and it tells you what it is right there. That's word for word what it says, so you don't have to copy that down. And what's more important is, in other words, it's a bunch of numbers and letters and exponents mushed together with multiplication or division. And I put division in parentheses because, remember, I'm always saying multiplication is the same thing as division and vice versa. So you just remember a bunch of numbers and letters and exponents mushed together. You should be okay on what a monomial is. Let's see some examples. First, x squared. Okay, that is a monomial. It's a letter and an exponent mushed together. Here's another one. 4 times x squared times y cubed times c to the fourth. Again, another monomial. These are now have a number, the letters, and the exponents all mushed together. Typically, when we think of monomials, we think of these types of monomials. However, we also have the number 2 or any other single number for that matter. That is also a monomial. It's a special kind of monomial called a, who remembers? I'm going to wait. Good answer, those of you who answered. It is a constant. Very good. And by the way, if you feel like this is an episode of Blue's Clues or Dora the Explorer or your children's show of choice, good, I'm doing my job, which is teaching, because that's what those shows do. Anyway, so yes, 2 is also a monomial, also a constant. And then, of course, you have big ugly beasts like this thing, -3 SNE squared p r to the fourth divided by 4 elemental p. That is also a monomial, because, again, it is all still one term, letters, numbers, exponents mushed together with multiplication and division. Yes, there's a negative sign, but that just means it's a -3 on top, or maybe it's a -4, but it's still just a monomial. Now, these are some non-examples. Note, x plus y, 3x squared plus 4x plus 5, 1 minus 4, negative, let's see, close that thing. Nope, didn't want to do that. Sorry. -9x divided by 4y minus 6p plus 4z squared. Okay? Sweet. These are all non-examples of a monomial. Now, why aren't they monomials? Guesses? Again, waiting. Excellent ideas. Biggest difference is these are not single terms. Okay? This 2 terms, this is 3 terms, this is 2 terms, this is 3 terms. They're not single terms. Okay? So when they're not single terms, that means they have numbers, letters, exponents split up by a plus or a minus sign, and we call these polynomials. Okay, polynomial. Monomial, single term, polynomial, multiple terms. That's another good way to remember which one is which. Okay, all right, I'll pause for a second to give you guys time to take any more notes. Okay. Next up, part 2, video presentation. Okay, I found this guy online. His name is Mr. Gill, from people calling themselves as Mathfolio, and he does a pretty good job of explaining the next chunk of this section, which is the actual multiplying of the exponents. So I'm going to have whoever's running this right now pause it, and everybody say thank you. They're going to pause it. While it's going, you're going to take notes, and you have the video sheet that kind of is lined up with this guy's presentation that he gives. He calls it a vid sheet. He'll refer to it a couple of times. Fill it out as you go along, and once he gets to the point where he starts giving practice problems, I'm going to have you guys pause because we still have a few more things to do, and then I'll give you your own homework assignment. So watch the video, take notes, learn from it, and then you'll have an opportunity to practice, okay? Go ahead and pause the video. Okay, so after watching all that, we can really summarize it in this one point. I know this is like 11 minutes worth of content, shuttle down to one graphic, but basically you just have to remember that when you're multiplying exponents, that means you add the exponents, okay? We spent a lot of time talking about it. I also like how he talks about the real world applications and so forth, but really it all comes down to this. Anytime you've got a monomial with multiple bases with the same base, but multiple different exponents, all you do is add those exponents together and keep the original base, and that's what you end up with. Now, part 3, power of powers. Okay, so when you take the exponent of another power, you multiply the exponents. Okay, again, confusing, but look at the example. Let's say we have something like x cubed to the 4th power. Okay, so x to the 3rd to the 4th power. Well, what I would do then is I'm going to multiply the exponents. So x cubed to the 4th becomes x to the 3 times 4 power. And 3 times 4 is, pause, very good, x to the 12th is what we end up with. Okay, now, why? Well, let's think about it. If we start off with x cubed to the 4th power, well, we take it to the 4th power, that means we're taking what's inside the parentheses and multiplying it by itself 1, 2, 3, 4 times. So we have x cubed times x cubed times x cubed times x cubed, and since we now know with multiplying exponents, we're just adding the powers. That means x to the 3 plus 3 plus 3 plus 3 plus 3, because they all have the same base, so we can do that. 3 plus 3 plus 3 plus 3 is x to the 12th power, right? Right. Okay, pause for notes. Let's continue. In summary, taking powers of powers means multiply the exponents, okay? I'll pause again so you can write that down. Okay, part 4, power of a product, okay? Remember, product means which operation? Addition, subtraction, multiply, or divide. Pause, multiply, very good. When you take the power of a product of more than one number or variable, you take each number or variable to that product individually. Okay, a lot of words. Let's look at an example. Let's say we start off with something like 3xy cubed, and then that's inside the parentheses, and we square that. Okay, well, what that means is I'm going to square everything in here. So I'm going to square the 3, I'm going to square the x, and I'm going to square the y cubed. Okay, so now we have to apply a couple different rules here, but we'll end up with 3 squared is 9, x squared stays as x squared, and like we just learned, y cubed squared, okay, that's us squaring a power or taking a power to another power, so we multiply these and we get y to the 6th because 3 times 2 is 6. Okay, again, pause, make sure you copy that down. There's the arrow. Pause, let you copy that down, and we'll move on. A little technological glitch there. So, in summary, taking powers of products means taking the power of everything in the parentheses. Okay, and I will go ahead and say, let's pause here so that we have time to copy that all down. Okay. One last thing. Remember, simplifying Well, we're going to have to do that again. Remember, we talked about simplifying is getting it down to where we have no more like terms, okay? This means something similar in the fact that we're going to take this big ugly beast, okay, the quantity 3xy to the fourth squared times the quantity negative 2y squared cubed. We're going to take all that and we're going to get it simplified down to 576x squared y to the 14th. Now, this breaks it down step by step how to do it. As you can probably guess, this is also taken right from your book. So again, don't worry about copying this down. It's right there for you. But notice how it works it all out step by step. They give you explanations of how they can do each thing and show you how to get the answer. One thing I do want to draw your attention to, this study tip, okay? It says when simplifying expressions with multiple grouping symbols, and remember grouping symbols are parentheses like here and here, or the brackets on the outside of this, then you begin at the innermost expression and work outward. In other words, start in the inside here, square that, then do this, then do that, and by this and that I mean the other grouping symbol. So work your way inside out. That should help you get there. And again, they give you a nice example of it here. Remember, work inside out. So, few notes for you to sleep on. Number one, I know I just dumped a lot on you, okay? You've been sitting here for about 25 minutes almost. That's a lot, and I appreciate your patience and your assumed cooperation with whoever's running this video. Don't disappoint me. Number two, if you're feeling a little overwhelmed, it's going to be okay. I know we're doing a lot of stuff, but once you get the hang of it, this is way easier than what we were doing last chapter. And I think if you're anything like me, you'll actually kind of like this once it's all said and done. Now, try the practice problems for homework. Okay, we will do more on this next class. We'll have more practice. You have an opportunity to work with other students and compare notes and so on and so forth. So, again, rest easy. Do the practice problems though. Don't say, oh, this is hard and then quit. You got to try. Okay, you got to try. I promise once you get the hang of it, this will actually turn out to be pretty easy. But you got to work to get there. Finally, go to Schoology. Okay, I know we haven't hit that a lot this trimester, but it is still there as a resource. This entire slideshow is there, so you can go through the slideshow at your own pace and read my notes. And this video also is linked there, so you can go to the Schoology site, get the YouTube link, get on YouTube, and then you can actually watch this whole video just in case you desire my mellifluous voice to really bring you to a nice level of mathematical zen. Or not, I won't be offended either way. It's entirely up to you. Now, last slide. Go to Schoology if you haven't already. Here's your access code for third hour. Here's your access code for fourth hour. Okay, write that stuff down. This is the end of the video, so this can stay up and on pause or whatever. So this everybody can see this. I You can go to YouTube. I don't have the link here, but again, it's on Schoology if you get there. And then finally, here's the homework for the day. Okay, page 394, 1 through 19 odd. That's all. Okay, that's all the check your understanding homework. It's all the odds. So what do I expect you to do? Check your answers in the back of the book. Okay, doesn't mean copy them out of the back of the book. And I will say this. I am fully aware that this section lends itself to just copying, and it also doesn't lend itself to always showing a bunch of work. Okay, show work whenever possible, but some of them you are going to be able to just do in your head. I'm trusting that you're not copying. Okay, if you're copying, you're going to fail your quiz and your test, and then I'll know, and it'll be too late to do anything about it. Be honest, be responsible, do the work, check your work. If you're getting it wrong, fix it. Okay, that's all for today. I already miss you guys. Can't wait to get back to you. Right now, work on these, what is it, 10 problems or so, and we will be back tomorrow with some more practice on this material. Love you all. Have a great day.